Assalamu alaikum warahmatullahi wabarakatuh. Today we'll be talking about the coupler chapter in our KNX advanced course. The coupler chapter will have 3 questions in the theory exam, okay? And in our question bank we'll have 61 questions. Let's have a fast revision on a quick recap on this chapter. We talked about the couplers before in the basic course. Remember this one? In this basic course we're talking about that couplers are connecting lines together or connecting areas together. Okay, remember in the topology we said that we'll have in our topology lines. This is a line segment with maximum 15 line connected together via line couplers. Remember this? And then they are connected via line coupler via main line. Okay, we have 2 power supplies, one covering the devices in the line segment and one power supply covering the device on the main line, which in our case are the line couplers. Then we can connect those lines together on a backbone line using backbone couplers to reach more areas. So we have 15 line per area and then 15 areas. Each area can have 255 devices, okay, because we counted the coupler already. And I can still also put devices on the main line, but I cannot put repeaters. Repeaters are not allowed on the main line or the backbone line. And that was the representation using the physical couplers. So we said that this is a line coupler. The address is within the segments I have. This is a line coupler. This is a line repeater, by the way. Sorry, this is a line repeater. This is a line coupler. So it always ends with 0. This is a backbone coupler, always or area coupler, always end with 0, 0. Okay. That was in the basic course. Today we're talking about the couplers in a some sort of more advanced way. So couplers are system devices that will connect hierarchy together. They allow transfer data between electric independent ports. They have a filtering table. This is the most important thing of the couplers. Using the filtering table, they will be able to route or block the device, the traffic I have. So they can route or block the traffic I have, which will lead to reducing the traffic on my bus. And in the KNX secure part, when we come to the KNX secure, we'll also talk how those couplers can increase my security settings on the KNX bus. This is another representation. We are talking about line repeater, line coupler, backbone coupler, and as we recall, it is the same device. Here it is a line repeater used to segment the line. Here it's connected in parallel, and we'll talk about this by the end of this chapter. Why I should connect line repeaters in parallel, not in series. Then I have line couplers. You can see it ends with 0, connected together via main line, and via this main line I'm putting another backbone coupler or an area coupler connecting the devices together. So this hierarchy. The new thing in the hierarchy is the gateway. Gateways are not like couplers, so they are different. Gateways mostly talk to KNX destination with different installation, meaning like KNX, another protocol like Z-Wave or like BACnet. In this way, it's not only filtering or routing telegrams. In this way, it is putting the telegrams in another language so the other one understand this as well. Okay, so it's not fully integrated into KNX installation. There is no filter table. Okay, it has a different way of assigning address and group telegrams, which is the table. And by the way, visualization softwares that we'll talk about in this course as well are also can be considered as gateway, because they will allow also connecting KNX installation with other installations as well. This is a line coupler. Okay, this is a TP coupler because it's connecting TP to TP. Okay, so this is sort of a coupler. This device can be used to act as a line coupler, a backbone coupler, or a line repeater, in our case amplifier. A line repeater does not have a filtering table. Okay, that was clear. And the distinction between, the difference between, is it going to act as a line repeater or as a coupler, is the application software that you will choose during your inserting the device in the ATS. Okay, so the same device, the same hardware that you bought will be able to work as a line coupler or a backbone coupler or a line repeater based on your need and definition, and based on your choice the address will be assigned as well. Okay, here we are comparing between line couplers or TP couplers in the old history of KNX and the new history of KNX. Okay, so in the old devices which were before 2003, we had some, let's say, shortage, which was somehow implemented in a better way in the new device. Mostly you will not see the old devices now. However, we have to cover this because it comes in the exam and because you might have to support older installation as well. So the first thing that you will be able to see that the older ones had a lithium battery, so they come with a battery. The new ones, no, they don't come with a battery because they have a non-volatile flash memory, so they can save the data without, even in case of power shortage. Okay, the power of the supply to the old ones were supplied via the secondary line, energy supply via secondary line. The new ones, energy supplied via primary line. Okay, the old ones has shortage in memory that was making the group addresses 0 to 15. Not always all of them are passing. They can support 0 to 15, but they don't filter or were not able to deal with group addresses 14 and 15. Remember, our group address can start, the main group address, from 0 to 31. So I can have a group address of 0, 0, 1, or I can have a group address with 31, okay, and then some other ports. So the old ones were not able to deal with group addresses 14 and 15 or above, of course. Okay, they can only support until 15, but they cannot deal with 14 and 15. In the new setup, they can deal with 0 to 31. And this is why you will see in the configuration, in the parameters, or even of the new couplers, we still have some settings for those group addresses, even in the new ones, because they want to have some kind of compatibility with old ones. Okay, these are the parameters of a coupler. So the coupler will have this kind of parameters. Okay, what do we have here? Let's first see those two settings are not available anymore in the new coupler, so we will not see them. They are internally now. That was the related to the filtering table, if they have an error in the filtering table itself. Okay, so we will not need to cover that. Then the coupler itself has the function of, the coupler will have, as we talked about, two lines. Let's say I have a coupler here, I have a main line here, this is a main line, then I put a line coupler, and I have here devices, I have here devices. And the line coupler objective is to act as a doorkeeper. Should I allow traffic to come from this way to this way, or from this to this way, or not? This is why you will see that you have always these settings. Should I allow group telegrams to pass or not, from this direction or that direction? Okay, so I always have normal, which is filtering, depending on the filtering table, or route, so always route, pass, or block. So it's either check and based on the filter table I route, or I don't check and I route automatic, or I don't check and I block. Normally I keep it as normal or filter. Okay, the types of traffic are normally, it's the group telegram, so group address or physical address, individual address, which I use during the ETS operation, or maybe I have some other, or it's an acknowledgement. Okay, so here we'll find that we talked about this part. So normally you'll find this one, normally keep it route. Okay, here is the repetition. If some devices here send to do the line coupler, and the line coupler find that it's not allowed to pass this traffic, okay, so the device, the data is not reaching, should I allow, and then I will send a negative acknowledge, or I will, that this receiver, this device will not get any acknowledgement? Should I allow the device, okay, to repeat the errors on main line, to repeat again, because by default it should be repeated for 3 times. Okay, this is why we have here a repeating only. And should I allow confirmation? Should I send confirmation on main line? Yes, only if routed. So only if I'm routing, then I will send the confirmation to the device sending, telling the device that we received the data and it's routed. So you don't have to do repeating again. Okay. This will lead to some specific case related to visualization or any PC that you have on your setup, because the PC doesn't have an individual address in the case of visualization, as an example, or a server like that. Then it will not be routed in the normal way. So our case here is I have a main line, then I have a line coupler, then I have device, and I put my PC here on the main line. Okay, so the case is what? the filter tables, I will allow here filter tables to route traffic from here to the PC. However, the PC will not send acknowledgement. Okay, so telegrams are now routed and the positive signal is not there. So this device will not get from this PC acknowledgement, so it will send again. So what can I do? We have two options here. You can say that couplers respond, so this PC will not send acknowledgement, but the coupler will send the acknowledgement. In this way, in this case, the device will find that the PC received the data. Or I can tell the coupler this way, okay, repetition on the main line is not allowed. So in case even you do not receive an acknowledgement, don't allow repeating the telegram again. Okay, this is the first case. We recommend using this one, not this one. However, if the PC here in a secondary device, okay, the first option will not be allowed because you cannot allow all devices to have positive acknowledgement. It will affect all the traffic in this line. Okay, so you will end up only with the second option, which is, okay, tell the device not to repeat the signal again. Okay, and by the way, we normally put our PC and our, let's say, security devices on the main line, not in the secondary line. In case of repeaters, we don't have a filtering table, so settings are less in case of repeaters. So I don't have any filtering. What I have is, should I repeat errors or not? In case of physical address, this is address or group telegrams in the main line or the secondary line. Even in the repeater, we have a segment, a line or a segment. It looks like a main line or upper line or lower line. Here we're talking about physical addressing. So this here we're trying to describe the way telegrams will travel to couplers or via couplers. Okay, here my telegram is physical addressing. Okay, physical addressing meaning it has a structure of area, dot line, dot device. Great. If I'm talking a main line and I want to pass via the main line, the first check will be done is if the physical address of the destination is related to the same like the coupler. So if the area is okay, then I can pass it again. I will check again. If the line okay, then I check again. If the device number is 0, then this is a programming to the line coupler itself. The destination is the line coupler itself. Okay, then I will start take action on it. Okay, if not, then it's going to a device in the structure. So I will allow it, and I will not decrease the counter, the routing counter. Remember the routing counter, we talked about it in the basic course. Routing counter is simply all devices start sending with a counter called routing counter. It starts with 6. The only exception is ETS. ETS telegrams will have a value of 7. And then line couplers will check. And if the line couplers are passing a telegram, they are decreasing it by 1. So a line coupler is decreasing it by 1. The second line coupler is decreasing by 1. If it reaches 0, then it will not be routed. Okay. Only exception is ETS. It is coming with a round counter of 7, and they will not be decreased. Okay, because of programming and troubleshooting, of course. That was the main here. Okay, let's say I am routing from line to main line, almost the same situation. So if it is allowed, then it will go. Okay, if not, then it will be blocked. That was physical address. Group telegrams is a bit different because I need to check the group address itself. Will it be allowed to route or not based on the group objects in the group address, which group objects are also going to individual to devices. And they have a routing counter. So the main line is sending. I am checking is the group telegram using the filtering table. If yes, if the routing counter is not 0, then yes, then I can pass this one and I will decrease it by 1, the routing counter. Okay. In case it's not in the filtering table, I block. Okay. In case in the filtering table, but the routing counter is 0, then I also block. Okay. And if I'm blocking, okay, then I also send a negative acknowledgement. If not, then I'm decreasing and passing. But if the routing counter is 7, then I'll pass it without decreasing because this is ATS, so I don't decrease it. Okay. This is only for filtering group address. What should I remark here? Triggers are only passed in line that really require them and not routed to places where they don't have effect. Advantages, bus load is reduced, and also we'll talk about security as well later in this course. Okay, line repeaters do not filter. Good. They only need to use to be extension. Routing counter has the benefit that the faulty wiring will be decreased by 1. As a result, line repeaters may not be connected in series. Let's talk about this. Why I cannot connect line repeaters in series. Let's have the worst case scenario. The worst case scenario, I have 3 line repeaters in a segment connected in series. So I have line repeater 1, line repeater 2, repeater 3, and they are connected in series. Okay, so and I have here devices, of course, and then I have this segment connected via a line coupler, and the line coupler is connected by an main line, and then I have another backbone coupler, okay, connecting device together. Then this backbone coupler, there's also I have another backbone coupler here in another line, on another area, sorry, and then another line coupler on another line, and then also I have here line repeater 1, line repeater 2, line repeater 3. So if I have a device here sending, let's say I want to send to a device here in this line, in this second segment, it's coming with around the counter of 6. Then it's passing for this one, going 5, by this one, 4, pass this one, 3, then it's past the line coupler, it's 2, then it went to the backbone coupler, it is 1, backbone coupler will allow it to go here, but it's now 0, so it will not reach this line at all because it's reaching there. Okay, this why you shouldn't in this case put line repeaters in series. You have to put them in parallel. Okay, otherwise you will face this issue. So you have to know that some telegrams will not be able to pass. Good. Filtering table we talked about. We can edit the filtering table. So if I go to the line repeater or the line coupler, sorry, and with the right mouse, and we'll see this in the practical part. Then I will be able to see the filtering table and edit the filtering table as well from the ETS. Media couplers are couplers, but maybe a different media. So we talked about line coupler as a TP, twisted pair. However, I can have a TP to RF or a TP to IP. So I am routing or making coupling between different media as well. In this case, it's a twisted pair media. In this case, it's an IP media. Okay. This is a TP IP router. As you can see, it has TP side, IP side, which is Ethernet. In this case, it is this manufacturer is choosing to have also another additional DC, but in the modern devices, we don't have the additional DC. Okay. But why should I use a TP IP router? Many things. I can use it as an interface. I can use it to connect my TP system to IP systems. Then I can connect among buildings. Okay, I can use to access my TP system via the IP network. So it's a tunneling here, so I can use it as a tunneling. Okay, and I can use, of course, to filter filter traffic, because traffic also will be filtered via the IP router. Okay, how can I connect them? This is one settings. So I can have here a line coupler, then connect the main line, okay, to an IP router which will act as a backbone coupler, and then it's connected to the switch and to the LAN. This is a way, this setup. The other setup can be as a line coupler. So my devices are connected to the IP router from this side, and then they are all connected to the LAN. Okay, so this one was a backbone coupler, and you can see that the IP router is taking an address of 1.0.0 because it's acting as a backbone coupler. IP router will have two IP address, okay, to act with this direction, and individual address to act with this TP side. Okay, and we will see this in the configuration in the practical part. You don't have to worry about that now. Then I have these settings. Then I have something like that. It's the line coupler, so devices are here, and traffic will pass from here to here and can also pass from here if the filtering table of this line coupler, in our case it's an IP router, allow that. And I can have a mix. So I can have here it's acting as a line coupler, here it's acting at a bit as a backbone coupler. Okay, but notice that you cannot have two IP routers in the same setup. So meaning that here I have it as a line coupler, right? I cannot put here another IP router and say that I will use it here as a backbone coupler. So you only have one setup of one router connected to the network. Okay, I don't need it, but it's not logical, but you have to know that because sometimes it comes in the exam. In the network settings of the IP router, you'll have an IP address. It can be manually assigned, static, or it can be dynamically assigned. In this case, you have a DHCP server that assigning address to the router. Okay, parameters of the IP router are very simple. You have IP settings, which is the addressing. You have general settings, okay, and you have like the IP settings and stuff like that. And you have the normal settings. So should I filter behavior or a telegram confirmation? Should I filter traffic from the bus to the KNX and vice versa? Not will happen in the telegram confirmation. And we'll see this inshallah in our practical part. Okay, we're done now with the coupler part. If you have any question, let us know, and see you inshallah rabbil alameen in the next chapter. Assalamu alaikum.